We are going to start now lecture 10 of chapter 10 class 11th mathematics straight lines. In this lecture we will talk about the change or transformation of axes. So we are having two kind of transformations. First is, suppose this is the x axis and y axis that we have, and we are talking about that the axis we are rotating. The new axis we are saying that this x axis is rotated by an angle theta and this y axis it is being rotated by an angle theta. So this is the pure rotation we are saying, that the new x axis and y axis, these are this. Or another thing we can do is we can shift the origin. We are talking about this situation over here, and this was the origin, this is x axis, this is y axis. Now we are saying that we have shifted the origin to this point and these are the new x axis and the y axis. So this is the pure rotation and this is the shifting of the origin. So whenever we are talking about, suppose I am saying that I am considering the xy plane and I am talking about a line over here, then if I rotate the axis, I have some equation of this line over here, and if I rotate the axis, the equation of this line will change. It will be in x dash and y dash. So we have to study these kind of transformations over here, that if we are rotating these axes or we are shifting the origin, then what kind of change is there in the given equation. So we are saying that the process in coordinate geometry, this process in which we are changing the equation corresponding to the coordinates that we have chosen, that is called the transformation or change of the axis. So these things will be more clear to you with our next slides as we will move towards the end of this lecture. So first thing we are talking over here, it is the change of origin or shifting of the origin. So we are considering, suppose we have, these are the axes that we have, this is the x axis, this is the y axis, we are saying this is the point O that we have, origin, and the new axis that we have obtained, the axis they are parallel to x axis, this new x axis it is parallel to x axis, this new y axis is parallel to y axis. The only thing we have done is that we have shifted the origin corresponding to these axes, this point is 0 0. We have shifted the origin to the point say h comma k. Then any point we are talking over here, we are saying this is the point pxy. What we will have? This length we are saying it is x. This length we are saying this is h. Similarly, when we are talking about this portion of the length, we are saying this length we have it is y and this length we have it is k. So the remaining portions over here, this portion we are saying this is y minus k, and this portion we are saying this is x minus h. So corresponding to these new axes, we are saying corresponding to these new axes, this point P, we are writing it is x dash, y dash is there. Now corresponding to the origin that we have taken corresponding to O dash, this length we are saying this is x dash. So what we obtain is that x dash is equal to x plus h, x minus h, and y dash is equal to y minus k. So the transformations that we obtain, it is x is equal to x dash plus h and y is equal to y dash plus k. So if any equation is given to us, we are talking about this is the point given to us, if we are talking about any locus is given to us and we use this transformation, then we are talking about the equation in the new coordinate system whose origin is shifted to the point h comma k. So we are saying that the axes are shifted parallel to themselves, the axis that we have shifted, the new x axis we obtained, it is parallel to the original x axis, and the new y axis that we have obtained, it is parallel to the original y axis, and this is called transformation by parallel axis. Next is inverse translation or shifting of origin back. So we are saying if this point is given, we can also obtain the coordinates corresponding to the point O, and the above transformation is true whenever the axes are rectangular or oblique. Oblique means, suppose I am talking about the polar coordinates, in that case also these kind of transformation can happen. So these are some properties mentioned over here. Now based upon this we have certain problems. The first problem we have, the equation of the curve x square plus y square minus 3x plus 5y minus 8 is equal to 0 when the origin is transferred to the point minus 1, 2 without changing the direction of axis. We have to find the equation. So we are saying these are the original axis, this is x axis and y axis. We are talking about that now the new axis they are shifted to the point minus 1 comma 2 somewhere over here, and the direction they are parallel to the given axis. This is x dash and y dash. The equation of this curve, suppose we are saying that this curve looks like this, something like this. This is the equation that we have corresponding to the x2x square plus y square minus 3x plus 5y minus 8. This is corresponding to xy coordinate system. Now we are saying that this point 0, 0 is being shifted to the point minus 1, 2. So the transformation we are going to do is, we are going to replace x by x minus 1 and y by y plus 2 in this equation. So this equation will become, on doing these transformations, this equation will become 2 into x minus 1 square plus y plus 2 square minus 3 into x minus 1 plus 5 into y plus 2 minus 8 is equal to 0. And on solving this equation, the equation we obtain, it is 2x square plus y square minus 7x plus 9y plus 11 is equal to 0. So this is the equation corresponding to this new coordinate system. Next is, find the equation of the curve refer to the new axis retaining their direction, and origin is 4 comma 5. Is x square plus y square is equal to 36. Find the equation referred to the original axis. Now we are having the opposite case. We are saying corresponding to these axes x dash y dash, the equation we have, it is x square plus y square is equal to 36. So we are saying x dash square plus y dash square is 36. Now we are talking about that the point, the origin is 4 comma 5. We are saying the original axes are over there. This is x axis, this is y axis, and corresponding to these axes, this point we have, it is 4 comma 5. So we have shifted it to this place. Now we have to calculate the equation of this curve corresponding to this axis. So the transformation we have to apply, it is x will be replaced by x minus 4, y will be replaced by y minus 5, and the equation will become x minus 4 square plus y minus 5 square is equal to 36. On solving this, we obtain x square plus y square minus 8x minus 10y plus 5 is equal to 0. So this is the equation of this curve corresponding to the xy axis. Next is, shift the origin to a suitable point so that this equation will not contain terms in y and the constant term. So suppose we are saying that this equation is being shifted, the origin is being shifted to the point h comma k. Then we will replace x with x plus h, we will replace y with y plus k. So this equation will become y plus k square plus 4 into y plus k plus 8 into x plus h minus 2 is equal to 0. Now on solving this, we obtain it is y square plus 2k plus 4y plus 8x plus k square plus 4k plus 8h minus 2 is equal to 0. Now, what we want is that the constant term should be 0 and the coefficient of y should be 0. So, on solving this, we get the value of k is equal to minus 2. On solving this, we obtain k is equal to minus 2. If we substitute this value of k over here, we will obtain the value of h is equal to 3 by 4. So, we are saying that the origin should be shifted to the point 3 by 4 comma minus 2. If the origin is shifted to this point, then this equation will be free from y, this term y and this constant term, and the equation will become y square plus 8x is equal to 0. So, this will be the equation in this case. Next is, at what point the origin be shifted if the coordinates of the point minus 1 8 becomes minus 7 3. So, again suppose we are saying that it is being shifted to the point h comma k, then we are saying that x is replaced with x plus h, y is replaced with y plus k. So, from these equations what we obtain is that minus 1 plus h should be equal to minus 7 and 8 plus k should be equal to 3. So, this first equation implies us that h is equal to minus 6 and the second equation implies us that k is equal to minus 5. So, we are saying that the origin should be shifted to the point minus 6 comma minus 5, then this point minus 8 1 comma 8 it will be shifted to the point minus 7 comma 3. Next topic we have is the rotation of the axis. So, suppose we are saying these are the x axis and the y axis, this is the origin O that we have, and the new axis that we are having, it is obtained by rotating these axes by an angle theta. These axes, these are rotated by an angle theta, this is x dash, this is y dash. Now, we are talking about any point P over here, this is the point P we are having. Now, if we draw a perpendicular from this point and we draw a perpendicular on both these axes, this is the perpendicular PM on OX and this is the perpendicular PN on OX dash, and we are drawing a line parallel to x axis over here, then what we have is that this angle we have, it is also theta. Now, suppose we are saying these lengths we have, it is OM, the coordinates of the point P, it is x comma y corresponding to the original coordinate system xy plane we are talking about. Then this length we have, it is x, and the length PM, we are talking about this length we have, it is y. The length ON, we are saying the new coordinate system corresponding to this new coordinate system. This length ON we are saying, this length ON we are saying it is capital X, and the length PN that we have, that is equal to this length PN that we have, that is equal to capital Y. So, if we measure the length OL, we are talking about the length OL that we have. So, that will be equal to the value ON, that is capital X into cos theta. And if we are talking about the value Qn, we are talking about the value Qn, the value we have, it is y times sin theta. This is capital Y over here, this value we have, it is capital Y over here. So, we are saying the value of x that we have, this small x that we have, that is equal to x cos theta minus y sin theta. So, this is one equation that we have, that the value of x we have, it is x cos theta minus y sin theta. Similarly, if we calculate the value corresponding to y, the value of y we have, this is capital Y over here, this whole length we have, it is small y. This part of the length if we calculate, and this part of the length if we calculate, we obtain the value of capital Y, that is small y, that is equal to x sin theta plus y cos theta. So, these are the two equations that we have obtained. Now, if we multiply equation 1 by cos theta and equation 2 by sin theta and add them, we obtain the value of capital X is equal to x cos theta plus y sin theta, and corresponding value of y we obtain, that is equal to minus x sin theta plus y cos theta. And if we talk about the value of x square plus y square, that will be equal to capital X square plus capital Y square, that will be equal to OP square, and these are unchanged, that is the distance of the point P from the origin will remain unaffected by the rotation of the axis. So, we are saying the transformations that we have obtained over here, it is y is equal to x cos theta plus y sin theta and y is equal to minus x cos theta plus y sin theta plus y cos theta. So, what we can see from this is that if the axes are rotated by an angle of theta, then we have to replace the value of x by x cos theta minus y sin theta and value of y by x sin theta plus y cos theta. And the inverse transformation, if we are talking about the inverse case, then the transformation they are given by this value. So, these things will be more clear to you with our next example. Next we have is the matrix method corresponding to it. We are saying the transformations in the matrix form, they are x and y, that is equal to cos theta sin theta. We are talking about the equations that we have, we can write it in this form. It is minus sin theta into cos theta into xy. So, we are saying if any point is given to us, so this is the point 2, 3 given to us, we are going to write it 2, 3. This is corresponding to this axis, xy axis. If we have rotated the axis by an angle of theta, this is x dash and y dash axis, then this point we will obtain by multiplying it with cos theta sin theta minus sin theta and cos theta, whatever the value of theta is there, you can substitute it over here. After multiplying these two values, you will obtain the coordinates of this point corresponding to this new axis. And for the inverse transformations, we can use this kind of equation. So, this is just the matrix representation of the given equation. Next is complex number method. So, we are saying suppose we have any complex number, we are having any complex number, it is z is equal to x plus iota y and capital Z is equal to capital X plus iota y, then we are talking about the rotation of the axis by an angle theta. So, we are saying that this small z, that will be equal to capital Z e raised to the power iota theta. So, this implies as x plus iota y, that is equal to capital X plus iota capital Y into cos theta plus iota sin theta. So, when you multiply these terms, you will again obtain the two equations in this form, that is capital X is equal to small x cos theta plus y sin theta and y is equal to minus x sin theta plus y cos theta. So, based upon the problem, we can use any of these methods to find the to find the new coordinates or the new equation corresponding to the new coordinate system obtained by rotating the given coordinate system. So, based upon this, the first problem is, if the axes are turned by an angle of 45 degree, find the transformed form of the equation this. So, the transformations we obtain, we are saying x will be replaced by x cos theta means x by root 2 minus y sin theta y by root 2, y is replaced by x sin theta plus y cos theta. So, using this transformation, this given equation will become 3 into x minus y by root 2 square plus 3 into x plus y by root 2 square plus 2 into x minus y by root 2 into x plus y by root 2, that is equal to 2. And on solving this, we obtain the equation in the form, it is 3 into 2x square plus 2y square plus 2 into x square minus y square is equal to 4. So, we get the equation in the form 2x square plus y square is equal to 1. So, this is the equation that we obtain. So, it is important to note over here that in the given equation we are having the term containing x into y. We have rotated the axis and the new equation we have obtained, it is free from x into y. So, if we rotate the angle by 45 degree, the equation we are talking about, it is free from x into y. So, we can look at this situation in this form. We are saying, suppose we are having some figure in this form. We are talking about this is having some figure in this form. This is corresponding to the axis x and y axis. We have rotated this axis by an angle of 45 degree. This is x dash, this is y dash. Now, corresponding to this axis, this figure has the equation 2x square plus y square is equal to 1, and this is basically free from the term containing x into y. Next is prove that if the axis be turned through pi by 4, the equation x square minus y square is equal to a square is transformed to the form xy is equal to lambda. Find the value of lambda. We have to calculate the value of lambda. So, again the transformations we have, it is x is replaced to x minus y by root 2, y is replaced to x plus y by square root 2. So, if we substitute these values in this equation will become x minus y square minus x plus y square, that is equal to this value we obtain, it is 2 times a square. So, if we open these terms, we will get it is x square plus y square minus 2xy minus x square minus y square minus 2xy, that is equal to 2a square. These terms gets cancelled. So, we are left with is minus 4xy is equal to 2a square, or x into y is equal to a square by minus a square by 2. So, we are saying that this equation we have obtained, we are saying xy is equal to minus a square by 2, and we are substituting this value is equal to lambda. So, this equation is transformed to the y form xy is equal to lambda, where lambda is equal to minus a square by 2. Next is, through what angle should the axis be rotated so that this equation may be changed to this form. It means, again we are talking about that we want to remove the term containing x into y. So, suppose we are saying that the transformation we are making, it is x is replaced to x cos theta minus y sin theta, and y is replaced to x cos sin theta plus y cos theta. Then this equation will become, it is 9 into x square, it is x cos theta minus y sin theta square minus 2 root 3 into x cos theta minus y sin theta into x sin theta plus y cos theta. Then it is plus 7 into x sin theta plus y cos theta square, that is equal to 10. On solving this, we obtain the equation in this form. When you open these whole square, you will obtain the equation in this form. Now, we want to make this equation free from the term containing xy. We are talking about, we have to equate the coefficient of this term is equal to 0. So, what we get is that minus 9 sin theta cos theta minus root 3 cos 2 theta plus 7 sin theta cos theta is equal to 0. So, if you solve this value, if you solve this equation, you will get that tan 2 theta is equal to minus root 3. So, the value of theta you will obtain, it is 60 degree, and if you substitute this value 60 degree over here, in these two equations, you will see that this given equation is transformed to the form 3x square plus 5y square is equal to 5. So, we are saying that the value of theta in this case, we are saying it is 60 degree, that is the axis should be rotated by an angle of 60 degree to obtain or to change the given equation in this form. Next question we have is, if xy, small xy and capital Xy be the coordinates of the same point referred to two sets of rectangular axes with the same origin, if ux plus vy, when u and v are independent of xy, we are saying this becomes capital Vx plus uy, show that u square plus v square is equal to capital U square plus capital V square. So, again we are using the transformations over here. It is x is equal to capital X cos theta minus y sin theta, and y is equal to capital X sin theta plus y cos theta. So, if we use this transformation, we are obtaining ux plus vy, that is equal to u cos theta plus v sin theta into x plus minus u sin theta plus v cos theta into y, and it is being given that this equation is of the form u y plus vx. So, we are writing u y plus vx, that is equal to u cos theta plus v sin theta x plus this value. So, on comparing the coefficients, we obtain the value of v is equal to u cos theta plus v sin theta, and the value of u we obtain, that is minus u sin theta plus v cos theta. So, we are having these two equations. Now, from these two equations, if we calculate the value of u square plus v square, we are calculating the value of v square plus u square, the answer we obtain, that is equal to u square cos square theta plus v square sin square theta plus 2uv sin theta cos theta. We are adding to it u square sin square theta plus v square cos square theta, and we are adding the value over here, it is minus 2uv sin theta cos theta. These two terms gets cancelled, and from the first two terms we obtain u square into sin square plus cos square is 1 plus v square, and this is what we have to prove. We are saying small u square plus v square is equal to capital U square plus capital V square. This is the result that we have to prove in this case. Next is double transformations. We are saying that both the transformations, they are happening, the origin is shifted to the point O dash and the axes are being rotated. So, if we shift the origin, we are saying the original point, it is, we are having pxy. So, the value of small x we will obtain, it is x plus x cos theta minus y sin theta. This is capital Y over here, and the value of y we obtain, it is k plus x sin theta plus y cos theta. So, you can consider this case as first the origin is being shifted and then the rotation is taking place, or you can consider this case as first the rotation has taken place and then we have shifted the origin. In both the cases, you will obtain the transformations in this form. We have combined both the previous transformations and we will obtain the answer in this form. So, based upon this, we have the problem over here. What does the equation, this equation is given, becomes when the referred rectangular axis, they are shifted to the point minus 2 minus 3 and the new axis being inclined by an angle of 45 degree to the old axis. So, we are saying x is to be replaced by minus 2 plus x cos 45 degree minus y sin 45 degree, and y is to be replaced by minus 3 plus x sin 45 degree plus y cos 45 degree. So, these equation will refer to this will give us that x is being transformed to minus 2 plus x minus y by root 2, y is being shifted to minus 3 plus x plus y by root 2. If we make these transformation to the given equation, we will obtain it is 2 into minus 2 plus x minus y by root 2 square plus 4 into minus 2 plus x minus y by root 2 into minus 3 plus x plus y by root 2. Next term we will have, this is the term xy, then it is minus 5 into minus 3 plus x plus y by root 2 whole square, then it is plus 20 times minus 2 plus x minus y by root 2, then it is minus 22 into minus 3 plus x plus y by root 2, and last it is minus 14 is equal to 0. And on solving this value, on simplifying this value, the final equation you will obtain it is x square minus 14xy minus 7y square minus 2 is equal to 0. So, we are saying these are the new equations obtained by, we are having two kind of transformation, one is the shifting of region and second is the rotation of the axis. Both these transformations are applied over here and the new equation we will obtain in this form. Next is removal of the term xy from f of xy is equal to ax square plus 2hxy plus by square without changing the origin. So, we are saying the transformations we have it is, we are just rotating the axis by an angle theta. These are the transformations that we have. If we apply these transformation to this equation, the equation becomes, these calculations these are shown over here, this equation will become a function of capital X and capital Y, and we want to remove the term containing x into y. We are talking about this term, we are substituting the coefficient of this term to 0. If we substitute the coefficient of this term to 0, we obtain that the value we are getting it is cot 2 theta. On solving this, you will get it is cot 2 theta should be equal to a minus b by 2 h. So, from this equation, we can calculate the value of theta by which the axis must be rotated, so that the given equation it transforms to the form the given equation transforms to the form which is free from the term containing x into y. So, an example is given over here, this equation is given, we are saying the value of a we have it is 4, the value of h we have it is root 3 and the value of b we have that is equal to 2. So, the angle we obtain in this case it is, we are saying tan 2 theta should be equal to 2 root 3 by 2. So, this implies us the value of theta we have or 2 theta we have it is pi by 3 or pi plus pi by 3. So, this implies us that theta is equal to pi by 6 or 2 pi by 3. So, we are saying that if the axes are rotated by any of these two angles, then the equation that we obtain on transformation of this equation that will be free from x into y. Next is position of a point which lies inside a triangle. So, in this case we are saying suppose a point P is there which lies inside the triangle, then it divides the triangle in 3 triangles, one triangle, this is second triangle and this is the third triangle that we have. Now, the area of the larger triangle, the area of this whole triangle we are saying it is delta, that should be equal to the sum of the area of the 3 triangles. We are saying that should be delta 1 plus delta 2 plus delta 3. Only then the point P will lie inside this triangle. So, this is the one of the conditions that we have. So, based upon this I have a problem over here, find the value of lambda. If lambda comma lambda plus 1 is the interior point of a triangle whose vertices are given. So, if this point P we are saying it is inside the triangle, then we are saying the area of the 3 triangles that should be equal to the area of the whole triangle. So if we calculate the area corresponding to all these values, we are having a triangle over here. We are saying this point it is 0, 3, this is minus 2, 0, and this point we are saying it is 6, 1. We have a point P over here. We are saying it is lambda, lambda plus 1. We are talking about 4 triangles. This is delta 1, delta 2, delta 3, and this whole triangle we are saying it is delta. So as per the question, this point is the interior point over here. So we are saying that delta 1 plus delta 2 plus delta 3, that should be equal to delta. So if we calculate the area of all these 3 triangles, we have used the matrix method over here to calculate the area of these 3 triangles. It is mod over here because area is always positive, and we are saying that this value should be equal to the area of the given triangle. We are talking about the area of this whole triangle, and on solving this we obtain the equation in this form. We are having the equation in the form, it is mod of 7 lambda plus 6 plus mod of 8 lambda minus 12 plus lambda plus 4 is equal to 22. Then using the wavy curve method, we have solved these values and we obtain that when lambda is less than minus 4, this thing is not possible. Again, when lambda belongs to the interval minus 4 to minus 6 by 7, this is also not possible. And last case we have is, the next case we have is for lambda belonging to this interval, the given equation is satisfied, that is the sum of the areas of these 3 triangles, that is equal to the area of the larger triangle, and at the value lambda is equal to minus 6 by 7, we are saying the area of the triangle PBC is 0. So it means that the value lambda is equal to minus 6 is not possible. Similarly, for the case lambda greater than 3 by 2, we obtain that we are saying, we are talking about lambda is greater than equal to 3 by 2. We are saying that this case is also not possible. So the only value of lambda which satisfies this equation, it is for the case when lambda belongs to the interval minus 6 by 7 to 3 by 2. So you can solve this equation containing the modulus function, that we have already, how to solve this equation we have already studied in our previous chapter, and you can obtain the value of lambda that belongs to the interval minus 6 by 7 to 3 by 2. So this is the required value of lambda.